Salam and welcome everyone. So today we're going to be working on the question on the screen that says the critical constants of methane are Pc equals 45.6 atmospheres, Vc equals 98.7 centimeter cube per mole, and Tc equals 190.6 Kelvin. Calculate the van der Waals parameters of the gas and estimate the radius of the molecules. So the first thing you have to know is this. We're told that the critical constants of methane are Pc equals 45.6 atmospheres, Vc equals 98.7 centimeter cube, and Tc equals 190.6 kelvins. The first thing you have to do is for you to remember that Pc represents what is called critical pressure, Vc is equal to critical volume, and then Tc is critical temperature. Looking at the volume in of itself, we see that we're told is centimeter cube per mole. This is not just volume by itself, this is actually molar volume. So this is actually the critical molar volume. That is what this is. And of course, that is basically the information that we're given. And then we're told to determine the van der Waals parameters, which are A as well as B. And then we're also told to estimate the radius of the molecule, which is just simply R, where involves the strength of attractive forces, and then B involves like information on the volume. So, or excluded volume, something like that. So, the point I'm trying to make is that these are the three things that we're asked to solve for. So, we can just go straight to solving it, but the issue is this: we are given the volume in centimeter cube per mole. And from your knowledge of physical chemistry, it's important for you to note that whenever you're dealing with molar volume questions, especially when they involve van der Waals gases, we tend to have the van der Waals parameters in decimeter cube per mole and not centimeter cube per mole. So what this is trying to tell you is that we have to convert from centimeter cube per mole to decimeter cube per mole. So we're going to go from centimeter cube per mole. Okay, we're going to do the conversions first before we can start solving to decimeter cube per mole. Okay, so what that looks like is that we have to remember that to go from decimeter to centimeter, we have to remember this, that 10 centimeter, okay, gives you 1 decimeter. So 10 decimeter cube is going to give you how many 10 centimeter cube is going to give you how many decimeter cube? So 10 times 10 times 10 would give you 1000. Centimeter times centimeter will give you centimeter cube. And then 1 times 1 is 1. Decimeter times decimeter times decimeter is decimeter cube. So this is basically the standard for the calculation for conversion. So we've got this, and then we've seen that our information is 98.7 centimeter cube per mole. I'm going to first of all ignore the per mole because we don't need that in this solution. So I'm going to put 98.7 centimeter cube, and I'm just going to call this, I guess, let me just say X. So let's cross multiply. It's going to be 1000 X centimeter cube, okay, or 1000 centimeter cube X, whatever you want to call it. It's just 1 decimeter cube times 98.7 centimeter cube. Cancel both side by 1000 centimeter cube. 1000 centimeter cube. So you cancel centimeter cube, cancel that out. So this would just simply mean X is equal to 98.7 times 10 raised to the power with negative 3 decimeter cube. Now, let's not forget that it's not just decimeter cube, right? It's decimeter cube per mole. So I'm going to write the updated VC to be 98.7 times 10 raised to the power of negative 3 decimeter cube per mole. That's basically how you solve this. Now that we have successfully converted, we can now continue with our work. To go from determine what A is, we have to go back to our textbook. I'm using the physical chemistry Atkins textbook, and in our textbook, we know that the van der Waals parameters, the formula for the molar critical volume or the critical molar volume VC is actually equal to just 3B. So the parameter B can be found because we know the value of VC. So finding B, we're just going to have B is equal to VC divided by 3. We know what our VC is because we've been given in the question. VC is 98.7 times 10 to the power negative 3 decimeter cube per mole. So we're going to have 98, okay, 0.7 times 10 to the power negative 3 decimeter cube per mole, okay, divided by 3. Now, I want to quickly mention something so no one is confused. I didn't just bring out this formula from nowhere. The Physical Chemistry Atkins 11th edition textbook has the formula for the critical volume in terms of van der Waals gases. So whenever you have a van der Waals gases, there is a formula for VC, just like you have the formula for perfect gas, PV equals nRT. There is the formula for VC, there's formula for TC, there's formula for PC. So the formula for the critical molar volume is equal to 3 times B whenever you're dealing with van der Waals gas, only for van der Waals gas. So anyways, you have 98.7 times 10 to the power negative 3 decimeter cube per mole. I apologize, not only for van der Waals gas, but whenever you're doing van der Waals gas, this is what you use. So 98.7 times 10 to the power negative 3 decimeter cube per mole divided by 3 will simply give you 0.0329 decimeter cube per mole. And this is basically the answer for B. So we've successfully found one of the parameters. Now that we know the value for B, we can go on to solve the value for A. And to get the A, right, we have to use another information, right? The other information we use is the critical pressure. And the formula for critical pressure for a van der Waals gas is A divided by 27B squared. All of this information is in the physical chemistry Atkins textbook, and also, yeah, also I believe also the way it's been derived. So yeah, that's it. So this is the formula we're going to use. B PC is equal to A divided by 27B squared. Don't forget we have the PC value. We're given that in the question. We have the B value. We've solved for that. Now all we have to do is find the A value. So that's just going to be, we're going to now like substitute. Okay, we're going to substitute the values we have to determine the unknown value A. So we see that PC, let's go back, is simply 45.6 atmosphere. So I'm just going to put 45.6 atmospheres, okay, equal to A divided by 27 and then B squared. So we're just going to say 27 times 0.0329 decimeter cube per mole, okay, all squared. So that's basically how it's done. So 45.6 atmospheres is equal to A divided by 27 times 0.0329 decimeter cubed squared is 0.00108 decimeter raised to the power of 6 divided by mole squared. Don't forget, we have all of this information, including the units in squared. So all you have to do now when you have this information, so in order for us to determine A, is just to simply cross multiply. So when you cross multiply, you have A is just going to equal 45.6 atmospheres times 27 times 0.0010821, and whatever that is what you get for the value of A. And when I multiply that in my calculator, what I end up with is 1.33266, okay, ATM DM6 per mole squared. So this is basically the answer to the question. But our work is still not done because it's just still not done. The reason why it's not done is because in chemistry, anytime you're given a chemistry question, you have to put your final answer in the lowest number of significant figures for the values in the questions you were given. So you have to go back to the question. We see that PC we're given is in 3 significant figures. We see that VC is in 3 significant figures, and we see that TC is in 4 significant figures. So we have to put our answers in the lowest number of significant figures that we're given. So you see here in B, we have 3 sig figs, 0.329. Now, for A, we have to put our answer in 3 sig figs because that's the lower number of significant figures in the values of the question that we're given. So A is going to be 1.33 atmosphere dm raised to the power of 6 divided by mole squared. So this is basically the answer to this question. Now, we have one more question to go. Remember, we're asked to determine A, B, and R. So the first thing you have to note is this. I'm also going to pull up another formula from the textbook that you need to solve this question. If you're asked to find the radius of a molecule of a van der Waals gas, you have to use this equation here, which is just B, the van der Waals parameters for excluded volume, equals to 4, okay, times the molecule's volume, or the volume of the molecule, times the Avogadro's constant, or number of atoms. So that's the Avogadro's constant. It's important for you to know that the molecules are regarded as spheres. So the volume of the molecule is actually just going to be 4 over 3 pi r cubed, which is just simply the volume of a sphere. That's the first thing. Then the Avogadro's constant. Of course, if you guys have done general chemistry one, you're not supposed to forget that this is your 6.022 times 10 to the power of 23 per mole. Okay, that's it. And the value of B is whatever you've calculated, which was already solved over here to be what? 0.0329 decimeter cube per mole. So I'm going to write that 0.0329 decimeter cube per mole. Now, I'm still not done. You see, we have the VB value. We know what the volume is going to be. We also know what the Avogadro's constant or number of atoms is. We also have to remember that here we have pi. We have to use the value for pi. And the value for pi that we're going to be using is just simply pi is equal to 3.1412. So now that we've gotten all of that information, we just simply substitute. So let me kind of separate this. So you have B like this for V molecule Na. So that would be B. That would be 4 times the volume of a molecule. That would be 4 over 3 pi r cubed. Okay. Na. So B was just simply 4 times 4 is 16. So that would be 16 divided by 3 pi r cube Na. So of course, since we're trying to solve for the radius, we're just going to um, rewrite this equation in terms of the radius. So we rewrite this equation above. So this equation right here, we're going to rewrite it in terms of r cubed. So rewriting this equation in terms of r cubed, what you end up with is just simply r cubed. Let me write it here. So it's a fresh page equals to 3b, okay, divided by 16 pi na. So this is how you get it. That is basically the work. So since we have that, we just simply substitute, right? So r cubed is just going to be 3, okay, times what is b? 0.0329 decimeter cube per mole divided by 16 times 3.1412 times Na, which is Avogadro's number, 6.022 times 10 to the power 23 per mole. 6.022 times 10 to the power of 23 per mole. So this is how you do this. So of course, let us cancel out the per mole, cancel out the per mole. You have decimeter cube. So you just have r cube is just going to equal 3 times 0.0329 decimeter cube. When you multiply the numerator, you have 0.0987 decimeter cube. And then you divide by what is in the denominator. You multiply 16 times 3.1412 times 6.022 times 10 to the power of 20 times 10 to the power of 23. When you multiply that, what you end up with is 302.7 times 10 to the power of 23. Yeah, that's it. So now, of course, you put this information in your calculator and do the division again. So r cube is just going to be 0.0987 dm cube divided by 302.7 times 10 to the power 23. When you put that in your calculator, you end up with 3.261 times 10 to the power of negative 27 decimeter cube. Now we can just simply determine the value for r by taking the cube roots of this information here. So we input this 3.261 times 10 to the power of negative 27 decimeter cube. When you take the cube root of that, you have r is equal to 1.48292 times 10 to the power of negative 9. When you take the cube root of decimeter cube, what you end up is just going to be decimeter. So this is the answer to this question, honestly. But our work is still not done because in chemistry, you pick the lowest number of significant figures given to you in the question. So looking at our work, we see that we have B to have 3 sig figs. You have values of pi, you have value for Avogadro's constants. Those are constants, so we don't really take that into account. But the value that we solved for was in 3 sig figs, which is the value for B. So we're going to put our final answer in 3 sig figs. So what you end up with is R is equal to 1.48 times 10 raised to the power of negative 9 decimeter. And this is basically the answer to this question. I'm going to be doing another question that is very, very similar to this one. So make sure you stay tuned. Just to give you a preview, this is what the second question looks like. So make sure you watch the next video on my channel, and there's also going to be a link to the video in the description. If you have any questions, make sure you email me at shahabitutoring@gmail.com if you want my tutoring or mentorship services. If you have any questions regarding what I just taught in the video, please put in the comment section and I'll try my possible best to answer you. I also wanted you guys to note that I teach students who are trying to succeed and be the best version of themselves in their academic career related to their STEM courses to succeed by tutoring and mentoring them. So if you want tutoring or mentoring in order for you to succeed in all your STEM related courses and to also guide you through your academic career, make sure you email me at shahabitutoring@gmail.com and I'll see what we can do together. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.